Okay, today we're going to work on learning about angles. And so this is another big set of notes with lots of vocab in it. So we're on notes number 3, and welcome to your first set of, or first experience with what's considered a flipped classroom. What a flipped classroom is that at home you listen to the lecture and you take notes. And then at school the following day, you work on homework. So that's exactly what you guys are going to do today. Now this comes out of lesson 1-4. So you can read along in your textbook. And I'm not going to write the date here, but our present date will be the 10th of September. Now you can either write 9/9, I don't care, or 9/10. Okay, so we're going to talk about some angles, and again, this should be fairly familiar material, and I am going to introduce to you 2 more postulates. If you remember from the notes we took yesterday in class, or today in class, the postulates are truths that we accept without needing to prove. They are the basis on which we prove other things. So there has to come a certain amount of a body of knowledge that we accept without anyone explaining where it came from or why it's true. We just accept it to be true. So here we go. Remember, if I underline it, it is a vocab word. So we're going to start with angle. And an angle, and it's really, please work on spelling. I don't want to look at angels when I should be looking at angles. So it's a figure formed by 2 rays. So remember that a ray has a definite beginning. So again, a ray has a definite beginning and indefinite ending. And that these rays are unique in that they have the same endpoint. So both rays start from the same point. Okay, the sides of the angle are the rays that form the angle. Oops. And the vertex of the angle is the common endpoint. Of the rays forming the angle. So again, what I like to do every time that we go through some vocab, I do like to illustrate it. So let's go ahead and draw a picture. We'll do that in a different color. Okay, so the sides of this angle would be ray BA and ray BC. So let's try that again. So remember, when we write rays, we always write the endpoint first and then a point on the indefinite end next. And then the vertex would be what they have in common, which is point B. Okay? Now, on angles, we need to name them, and so we have options depending on what the angle looks like. So to name an angle, you may call it by the vertex, and here comes the issue, and I'm going to go back and underline it, only if there is one angle coming out of that vertex. Okay. So the angle that we had just drawn, there was only one angle coming out of vertex B, so we could call that angle B if we wanted to. But if you want to play it safe, otherwise, you must use 3 points with the vertex being the middle letter. Okay. Now, this piece that we just talked about here about how to name an angle is not part of the definition of what an angle is. Now, if you want to include that in the vocab card to study it, you may do so, but it is not necessary. And we did have 3 separate vocab words with what is an angle, what are sides of an angle, what is the vertex of an angle. So let's talk about this guy. We're going to use the same exact angle we did before. And we have 3 names for this angle. Now, just like when we were naming other shapes, we will use the letters that name that shape if it's a segment, a line, array. We do with an angle. Now, when it becomes a polynomial, a triangle, we use the triangle symbol, but once it becomes 4 or more sides, we just name the letters that make up the vertices of that piece, and then by virtue of counting, we know what the name of that shape is. So this would be called angle ABC, or you could go the other direction, angle CBA, but note the location of B is in the center. And in this particular case, because there's only one angle coming out of B, you could call him angle B. Okay. Now, just as for a nomenclature issue, some people draw a slash through their angle symbol so that you don't confuse that with a less than inequality. Okay, so that's up to you. All right, we got some more vocab related to angles. The unit of measure is something called a degree. So units of measure. For angles. And we get to our cool tool, the protractor, which, by the way, I believe tomorrow we're going to learn how to construct things using our tools. So that's kind of fun too. So protractor is the tool used to measure an angle. Now, in my notes, I tend to abbreviate, so instead of writing the word angle, I can go ahead and use an angle symbol, so whatever is best for you is fine. So, I'm going to go to the next screen because I've run out of room here, but we need to do some really important nomenclature. And this occurred also when you're talking about identifying a line versus the length of that line. We have the same issue here. This means angle ABC. It's an object. When I want to know the size of angle ABC, I add a little thing in front, M, in front of that angle ABC. And that means the measure of angle ABC. So this is dealing with size. Okay, so it's very important that you understand that. Okay, so when you see this, measure angle ABC, you read it as the measure of angle ABC is 40 degrees. Okay, that reminds me to share something else. The book is really bad about putting labels in. So when it's talking about the label of an angle, it talks about the measure of an angle, it'll just say 40 in your book. I'm going to grade you making sure that you have the units of measure there. So understand that what I'm looking for on a test is that. I want to see it say the degree symbol on it, so be forewarned. Okay, we're going to talk about 4 different types of angles, from smallest to largest. And our smallest is, well, one of them is actually not the largest. An acute angle. An acute angle is such a cute little guy. He's an angle that measures, an angle measuring between 0 and 90 degrees. So 0 degrees to 90 degrees. Now, remember what the word in math between means. It means it does not include the numbers on either end. So it doesn't include 0, so it's got to be bigger than 0, otherwise it wouldn't exist. And it can't include 90 because we have a different name for an angle that equals exactly 90. In fact, that angle is called a right angle. And we come up with that word we have to be really cautious about, exactly 90 degrees. There's no other options for it. Okay, the next angle would be an obtuse angle. Oops, let's get that right. So obtuse means something kind of big and lopey, and so he's a big guy. So he's an angle measuring between 90 degrees and 180 degrees. And again, between means it can't be exactly 90, that's a right angle, and it can't be exactly 180 degrees because that is our last angle, a straight angle. So that's an angle measuring exactly 180 degrees. Okay, all right, so here we go into a couple postulates. So remember how we signify a postulate? It's a star and an underline. Now, just like with the 2 postulates we did yesterday, or actually today technically. If a postulate has a name, you don't need to write it out in a proof. You just write the name of the postulate. And that would be, for us, on this one, protractor postulate. Now, normally, I'm a super big stickler for writing exactly word for word what the postulate says or what the theorem says. But in this case, I'm going to paraphrase, because this is what postulate 3 actually says. On line AB in a given plane, choose any point O between A and B. Consider ray OA and ray OB and all the rays that can be drawn from point O on one side of line AB. These rays can be paired with the real numbers from 0 to 180 in such a way that A, ray OA, is paired with 0 and ray OB with 180. B, if ray OP is paired with X and ray OQ with Y, then the measure of angle POQ is equal to the absolute value of X minus Y. Okay. If you remember the ruler postulate, this is kind of the same thing but dealing with angles. So this is what we're going to say. We can measure the size of an angle using a protractor. Okay. Now, the one thing to take home from the actual postulate is to make sure that you understand that when you are trying to figure out an angle that doesn't start at 0 and go to a number, that's easy to figure out what its size is. It's whatever number the other ray is at. This is if you're talking about an angle that's somewhere floating inside that half moon shape, that 0 to 180. And so what you would do is take one angle that the ray passes through and the other angle that the ray passes through, and you'd subtract them, but you'd always take the absolute value because that distance has to be positive. So that's all that you really need to take home from that. This one is used rarely in our proofs, but it would be anytime you're dealing with the size of an angle, they bring into the proof the size of an angle, then you would be using the protractor postulate. Just like if they're talking about the length of something in a proof, that's the ruler postulate. So we will give you some examples down the line of using these postulates in proofs. All right, now postulate 4 is like postulate 2. Remember that we had the segment addition postulate. Well, now we have the angle addition postulate. And again, because of the name, in a proof all you would write is angle addition postulate. And remember, the numbers correspond to when they show up in the book. It's not a universal number. So this is what it says. And we have actually two parts to it. If point B is on the interior of angle AOC, then, so an if-then statement, the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. And so I want to put a picture in here to illustrate this. Basically what it's saying, instead of that basic angle, we actually have an additional ray. So here's point A, point B, point C, and the vertex is O. B has to be between A and B. So basically what it's saying is this little angle plus this little angle together equal the entire angle. And that makes sense. The two angles are not overlapping, they butt up, they have a common side, and so that's perfectly acceptable. Okay. Now there's another way we can take this postulate and use it. Then this comes up a lot in proofs. If angle AOC is a straight angle, and remember from just a few minutes ago, a straight angle is equal to 180, and our point B is not on that line AC, then instead of us saying little angle 1 plus little angle 2 equals big angle, we know what the big angle equals with a straight angle. We would say the measure of angle, AOB plus the measure of angle BOC is going to specifically equal 180 degrees. And then I'll put a little picture to illustrate that. So here's our AC, and here's B. So angle 1 plus the measure of angle 2, measure of angle 1 plus the measure of angle 2 has to equal 180 because it has to equal a straight line. Okay, a couple more special vocab words and then we'll be done. Next, congruent angles. And we know that the term congruent means they're the same. How are they the same? They're angles that have equal measures. So, do a little bit of an example here. Let's change up to a little purple. So we've got this angle, R, and we're told he's 40 degrees. We've got this angle, S, we're told that he's 40 degrees. And so since the measure of angle R equals the measure of angle S, we can therefore recognize that the angles would also be congruent. So this notion of congruent and equality is interchangeable and goes both directions. It comes up all of the time. And this is the one thing that the book is super bad at, that they make it a single statement in a proof, and we're going to always separate it out into its two separate statements. And again, don't worry, we'll get to that. All right, let's talk about adjacent angles. And I kind of alluded to that before when we were talking about our postulate 4. And these are two angles in a plane that have a common vertex and a common side but don't overlap. Okay, so an example of that. Where angle 1 ends, angle 2 begins. They don't overlap. They share that ray in the center, so that makes them adjacent angles. So angle 1 and angle 2 are, and here's how I abbreviate, ADJ for adjacent, and then the angle symbol, and then an S to give you an idea that there's more than one. All right, I've got one more. I'm going to go to the next page. And this is the bisector of an angle. And this is the ray that divides an angle into two, and here comes the key word, congruent adjacent angles. Okay, and the reason why I say that it's really important that you understand that what you get are two angles that are congruent. From there we can conclude they have measures that are equal. So here's a couple things we can look at in our example.